right now. So, what a great example. Yes, look at my talk. It's on GitHub. This is the code that I'll be showing in a moment. And it's just the same thing over and over. Oh, here it is. Okay, let me just do this. So there's a little bit of a thing on the bottom. Okay, I don't know what happened, but it did. And that's what I get for not making my own slideshow software. So, Python. Let's talk about Python for hopefully longer than it has been so far. Python is awesome. It's my favorite language. I love it more than anything. It's my first language. I will always fight for Python. I hate Rubyists. I love the code that I get from Python. I think that it's the most maintainable code that I write for production anything. I wrote PHP once, and I might have to do it this summer, so that's sad. And it's not very fast, and that's okay. CPython was never meant to be fast. It was meant to be awesome for programmers to write in, and I'm sure you all agree because you're here right now. But sometimes we do need fast code. Sometimes you have like, oh, I need this critical path, and it's not the database that's the bottleneck, it's the app. It's taking too long, something or other, and Python pointers that are, everything is reference counted. Something is going wrong, and it's CPython's fault, which is the default interpreter. So we reach to C extensions. You get the speed of C, you get to use Python as the main point of everything, which is still the idea. You have just some C code in the back that does the heavy lifting. But when you have a C extension, you have C now, and nobody wants C in their code base because it's terrible. Sorry, I have very strong opinions.
Keep in mind that C is the origins.
I know, but that doesn't mean it's
the origins. You just recognize it what it is, and it has evolved.
I'm not going to get into it. I'm just going to say that I like Rust better. Yes, it is. C is our origins. Yes, C made CPython, so we should be happy that we have Python because of it. But I don't want it in my code bases if I don't need it. So enter Rust. We don't have header files anymore. Wow, that's like immediately. People are like, oh, I tell C programmers I talk to, oh, no header files, thank God. You get type safety. Not everything is not an int. That is the best part. You actually have types. And then it's modern. It takes, you have, if you do any functional programming, because once the creator was really into that, there's algebraic data types, there's type classes, there's immutable by default, which is awesome, there's good generic support, there's no null. Okay. No null pointers in safe Rust code, thank goodness. So to write a C extension in Rust, we need to go down to C just a little bit. We can't have all the niceness. We can't have impls like we did before, like I showed you before. We need to go back to functions. So we're gonna have constructors in the same vein, and it gets a little bit more wordy because we're using libc. And so when we're using libc, instead of f64 we say libc double, libcc double, which is just a type def for f64, but it's nice to have. To use the C terminology because it's the same in the Python ctypes, which we'll talk about in a few minutes. And we're also talking about pointers. So Rust doesn't have raw pointers in safe code, which is also good. You can't dereference a null pointer because once again, null pointers don't exist. There's no dangling pointers. There's no iterator invalidation. I could go on. There's no data races. So we have boxes, which are unique pointers. And they're managed. The compiler knows when to deallocate them. So we use them a lot. Whenever we have to. So we have the same stuff here. We have origin, which just returns a boxed point now, because everything in Python is boxed in a pointer. There's no value types in Python, so we just box everything that gets sent to Python. And whenever we take it back, we also have to take it back as a pointer now. And then, wow, that got really long, actually. So it's the same code, I swear. I didn't try to trick you. Alright, ctypes. Ctypes, which I hope you all came here for my talk, even though that talk was awesome. Because ctypes, everybody needs to know ctypes. We're going to talk about defining a class really quick. I don't know how much time I have, by the way, so just signal to me. I can be as fast as, define arguments and return types. So we need to do all these certain things. We define the class that we'll be using, which is a C structure. We're defining the types that we'll be using of the stuff. We do something in the middle, and then instead of profit, we're going to go free, because we need to free the memory, because it's still C in the end. Thank you, somebody. I make a lot of bad jokes. It's okay. So when we're defining a C pointer in Python, it's generally in all caps because it's scary. And so from ctypes, we're going to derive from a structure. So CPython knows that this is a C, something we're going to take from C. And the fields takes a list of tuples, which is so when you're defining a struct in C, you have x and y as a point, and it's the same way. You have x, which is C double, and y, which is a C double. So that's pretty easy. You need to derive from structure. I don't know if the field names need to be the same, but I think it's a good idea. I'm pretty sure they do. I haven't tried otherwise because that's just a lot of work. Types. You should be using like C types, C double, C int, C void, whatever, or which is just none actually. So there's no C void. Is there an actual? Yeah. So we're gonna compile a program into a DLL, which is the shared object. Sorry, I'm on Windows, so it'll be an SO or a dilib on Mac if you use the code. So you're gonna take the DLL. And then you load it into Python, and then you say the return type and the arg types. So I'm going to first say that there's a new library called CFFI, if anyone's heard of it, by the people who make PyPy. And PyPy doesn't like Windows, so that's why I'm not using it, because I was trying, and then there's just a lot of problems with Windows and Python and C. If I was on my Linux machines, then I could, but no. So, I mean, it's pretty easy. The return type, I don't know, I'm pointing at my monitor. The return type for a new pointer is a pointer to a point, which is all gathered from the DLL. We can gather this, and it takes in 2 C doubles. And the argument type for origin is nothing, as we saw before in the Rust code. Yeah, we see origin doesn't take any arguments. And here's the empty argument list. Whoop, I went too far. Okay, no, I didn't. So let's go, and then whatever you do, you can, at that point, you have the code that you need to write. And generally, you shouldn't be like writing the types in C unless they need to be that fast. I mean, writing the structs and stuff, but that was just the easiest example to make. Generally, you're going to be taking in a Python object, doing like getting the contents of it, then you like do some crazy math, because that's probably what you need to do, because Python's not very fast at that. So you do some of the math or the computations that is bottlenecking you, and then you return the Python object back to the interpreter to use. So you wouldn't always need to free it. That's not as common as you'd think in this type of code. You do use a lot more C code than you guys think, because Python needed it in its standard library. So in this, I have the same. I could print this out, but it answers. I mean, it's math. Math doesn't change on processors generally. So yeah, let's do that actually. Even though I said I wasn't going to. In the short demo, which I have on my GitHub, which is pretty cool. So I got up the page. Let's go to Sublime. If anyone can't see anything, oh god. So many tabs. So let me zoom in for you guys. So I have the same code that I had before. I wanted to like write bindings for a really cool Rust library, and I don't want to say my excuse is that college sucks, but my excuse is that college sucks.
Is anyone working on Swig for Rust?
Swig? Yeah. I think it already exists. Okay. I mean, I haven't heard much about it, but I mean, Swig is for everything.
Right.
And if it's not, it's going to be soon, because Rust just hit beta, which I was going to talk about later. But yeah, so it's going to happen. I know it. I mean, it's for C++, and it can be done for C++. It can be done for anything. So we have the same code here. We're just going to run it. I actually had to run back there because I had 32-bit Python installed, and you can't run a 64-bit DLL in 32-bit Python. So I was pretty this is all in my GitHub repository. Oh, that's my class project. So in this, all I'm doing is I'm creating the binary, the DLL, the library that I'm using. I'm moving it into my local, into the top level directory, and then I'm running the DLL. So it's really easy to get that, because I mean you have DLLs for anything. You can just look in like installed, while you're installed program files, you'll see DLLs, and if you can figure out what ABI to use, and if Python supports the C ABI, if it has a C ABI, then you can just run it, and you can like look at it in Python if you're smart enough. It's kind of creepy sometimes. So release. So if I take that, and then from which I'll, so let's look at that. So the Python code is what I was showing before, but I defined a few extra methods. It's really straightforward. After you get past the bad API, ctypes, like I said, it's pretty old, but I'm gonna go introspecting it for a moment. So if I have that, if I'm in, can you guys all see that? Is it really terrible? Can you guys? I don't know. So if I look at the A object, then it's a point, and I can get the contents of the point. So I want the X value, and that's what you'd be doing in Python. If you're introspecting a C object, you do dot contents to get the contents of the value of the pointer. So X and Y of B, so I can do B dot contents dot Y, and it'll give me 0 because it's the origin. Point distance, A dot point distance B. Oh, never mind. I'm not going to do that. It gave me an error. So that's. I really wish I could have given you
2 parameters you pass in.
What?
I think you're supposed to pass in 2 parameters.
Oh yeah, because it's a function, not a method. So yeah, it's point distance AB. Okay. What do you want from me? Oh, it's rlib point distance. Whatever. And then there it is. That's 3 point something. So from here, I just want to talk about what I could have done and how I feel bad about how I didn't do it. This one. Nope, that's black. Never mind. I can't. It's just black. All right. So the end. No. So there's bindings to C Python itself, which is to the Py objects that you could be looking at, and that's what generally you'd be doing. This guy is a cool C Python binding, and it's a safe C Python binding. So he took the bindings and then he made it rustic, I guess, or rustaceous, or just, I don't know. There was a big discussion on IRC about that a couple days ago. I was really into rustic, but I lost. So that's a really great way to interact with Python from Rust. And once again, Rust is really awesome because generally you'd be doing a lot of behind-the-scenes stuff where you could be using Rust features and just exposing a minimal API to Python. That does look bad because it has to be C-like. And then HTML5 ever, which is my favorite library name. It's an HTML5 parser. Actually, I can look it up here. So it's HTML5 parser written in Rust. It's a browser grade. It's really fast. It does like no allocations. Starting in a couple days when he finally merges the pull request. It will. It already has a C API, and I'm going to write the Python bindings hopefully this summer because exams. And you're constantly studying for them. And so HTML5 ever is really awesome. And I mean, the way I would do here, if I just look at it for a second, is it defines the structs in the header file, which is basically a bunch of, give me a second to think, a bunch of function pointers, and that's what, I mean, you can do the same thing in Python. Oh, that looks more terrible. Hold on. I can't do that then. And it defines the struct, and there's no dark mode.
Just highlight.
Oh, that's a good idea. It's okay. Maybe if I just make it worse, just stare at it. Look how clear that is, though. Yeah, so it defines a struct, and you'd be doing the same thing. It defines a struct, and that you'd be looking back into from Python, and then you just interact with it, and it's really cool, and I'll hopefully do that eventually. And so that's, and also I was supposed to take that out because I just got a job offer today actually. So, no, internship. I'm not that popular. So I don't know. If you really like me and you think you can sweep me away, then please send me an offer so I can get out of college. Please. Questions? That's my email address. Feel free to email me whenever. My cell phone never leaves my side, sadly. I'm at Sinister Snare. I barely ever use Twitter, but I use GitHub all the time. Please look at that and then send me a job offer. Because you'll want to.
So we're going to like something like DirectX package, something like a DirectX package.
So
probably
DirectX
possibly be added to Python because you have something that can put the speed.
Well, that's written in like C++, and that's like no.
But what I'm saying is that using a language like Rust to get something equivalent.
Oh yeah, so there's actually, so you're saying like graphics libraries?
Yes.
Yeah, so really, there's really awesome people working on like GL implementations. If you look at like Glium, G-L-I-U-M, or Gluten, G-L-U-T-I-N, those are really cool people doing work on like OpenGL implementations in Rust. And yeah, I think I can convince them to write C API stuff, or I'd have to do it because I'm good friends with those people on IRC. And yeah, I forgot to mention Rust is almost hitting 1.0, and it'll be production ready. And April 15th, I think, it just hit beta, so there's like no more. If you heard that there's a ton of breaking changes, that stopped last Friday. So yeah, that's it. Any more questions? Anyone? All right. Oh yes.
What are the good resources if
Yes.
you want to jump in?
So rust-lang.org. All right. There's a book. On the top they have. I suggest looking at Nightly because even though beta is out, Nightly is still cooler. So look at there's the book. There's rustbyexample.com, which is no spaces or anything. Rustbyexample.com is just, oh, here's an example of file I/O. Here's an example of threading. And that's just straight up. It's really nice if you're the do by example kind of guy. And that's those two things. Also, IRC is extremely helpful for anyone. You just go into their IRC on Mozilla, irc.mozilla.net, and they will always help you unless it's just dead, which happens. It's not as rare. I mean, it's like the DC Python IRC channel is dead, but the Rust IRC channel is fairly active. So, all right.
Can you run and compile Rust on any platform right now?
Yeah. So any platform that's all right. In theory, any platform that LLVM supports. Right now, Zinc. If you go to zinc.rs, which is a really cool extension because it fits Rust's extension, so zinc.rs, it's for, they're writing a project to make like, right now it's just for ARM v6, but they're supporting they want to support a lot of low, like, microcontrollers and stuff like that, and they're supporting an API, and there's a really cool macro that, like, compile time does, like, the configuration for your specific controller. I don't even know, that's some cool stuff. But yeah, we support a ton of operating systems, Dragonfly, BSD, Haiku. I'm sure one day Plan 9 will get in there somehow. I mean, nobody even knows what that is, so.
Herd.
Yeah, Herd one day. New Herd. Stallman will be happy with us. And yeah, so I mean, and if you really want it on another platform, all you need to do is just write I don't want to say write the backend. I want to say like write the bindings for the specific LLVM API into the Rust backend, which isn't amazingly difficult, but if you want to, you could. Yeah. That's like anything ever though. Right?
So how slow is Rust compared to C?
It's almost just as fast. And almost just as fast in the sense that there was a benchmark a couple days ago on Reddit, and everyone got mad because of benchmarks. And it was like 0.035 seconds, and C was like 0.033 seconds. So it's right there. And the thing is, Rust, people will say like, oh, Rust is bounds checking, which is actually awesome, but for the way Rust does iterators, which is the same way Python does iterators, LLVM is able to optimize out the bounds checks on the iterations. So that's the main use of bounds checking, and it gets optimized out. So, and a lot of the stuff that Rust does is compile time abstractions, so it's just as fast as C would be, and it's much better because, okay, I'm sorry, C sucks. Yep. All right then.
All right. Last bits of